The following clip is about the key concepts you need to keep in mind when solving projectile motion questions. The first concept I want to talk about is the concept of direction. In projectile motion, the direction of up is given the positive direction and the down direction is given the negative value. So what this means is any vector in the up direction is given a positive value, and any vector in the down direction we give a value of, or a sign of, negative. The next concept I want to talk about is the path taken by a projectile is termed its trajectory. And the shape of the trajectory of projectile motion is a parabola. So there's something to keep in mind when you're starting to describe projectile motion or to analyse questions. If it asks for the trajectory, that's what it means. It's the path taken by the projectile as it falls, as it goes through the air. The definition of projectile motion, by the way, is the motion of an object under the influence of gravity only. Another key concept you need to be reminded about is the concept of maximum height. Maximum height is often referred to in problems, so you have to know what that actually means. And it is the distance from the top of the trajectory to the ground in a vertical direction. And we give that as SY as a symbol. S mean displacement and Y mean vertical. There's a couple of points you need to remind yourself about at the maximum height, and this is very important in a lot of problems, is that at the maximum height the vertical velocity is equal to 0 meters per second. This means the projectile has gone up and instantaneously stopped before it's returned back down. Another key concept at the maximum height is the time taken to get to the maximum height is equal to half of the total time of flight. Now this becomes very important when you try to calculate the range of the projectile, where it can only go across for as long as it is in the air. Okay, the next major concept we want to talk about is possibly the most important of all, is that at all points the only force acting is gravity, ignoring of course wind resistance, which we tend to do in year 11 and 12. Now if the only force acting is gravity, we can say that the acceleration is the acceleration due to gravity, which is just g. It's given as minus 9.8 meters per second squared. The minus, once again remember, up here means down, so we can simply write that, or we can alternatively write that as 9.8 meters per second down. Very important concept in all projectile motion questions. Another key concept, you may get the terminology range mentioned in questions. That is the range there. It is the displacement S in the x direction, or the maximum displacement in x direction, given the term range. So just remember that terminology. Now the next little bit of the clip is talking about the two different components that are evident in projectile motion questions. The first one is the vertical component, which has a symbol which is the y direction, or just vertical. And the other one here, which I'm going to draw some graphs down here, is going to be my x, which is the horizontal. Now these are two different components. when you're analysing problems, you can think of two different components occurring to give the net result of the trajectory. Right, so we look at the vertical direction first. If we look at the displacement in the vertical direction with respect to time, we would get this type of graph being drawn. Okay, that is how that distance there varies with respect to time. If we look at the velocity in the y direction with respect to time, we would get this type of graph. This point here being the top of the trajectory, that is, where the velocity is 0. It starts off being in a positive direction, changes direction at the top, starts coming down, so it becomes a negative direction. And it's a straight line because it is constant acceleration. Brings us on to the next one, is acceleration in the y direction. That's 0, positive, and negative. It is negative 9.8, so we have a straight line, doesn't change because the gravity doesn't change. Straight line in that area there. So these are the three graphs for vertical motion. If we look at the x direction, or the horizontal, if you look at the x displacement with respect to time, how quickly is this moving across in a horizontal direction? We would get a straight line up like so. It never goes back the other way, so it never goes below the horizon or the 0 point. If we then look at the velocity in x direction with respect to time, we get its constant velocity, so we get a straight line going across like so. And of course, acceleration in x direction is 0 because gravity does not affect the horizontal, it only affects the up and down. So we would find that we get a horizontal line on the 0 mark here. So there we have it. We have a good summary there of both the vertical and horizontal components. Remembering the vertical component is affected by gravity. Vertical motion affected by G, and the horizontal component, or horizontal motion, is not affected by gravity. Very important concept there. So I advise you to have these key points in your mind when you're solving these problems. It's okay to have formulas in your head and way to do problems, but sometimes I'll throw you some curly questions, and if you know those key concepts, you'll be better equipped to answer the questions.